In section 5.3, we're going to be solving linear programs. So let's take a look at a linear program and try to figure out what all of its pieces are and what they mean. So to begin with, every linear program has a function that you are trying to either minimize or maximize. And in this particular case, we have a function, well, we have this variable z that is defined in terms of x and y. So we want to find the values of x and y that make z a maximum and also a minimum. But we want to work under these constraints. So we have these this system of inequalities that we also have to satisfy. So the basic idea is this system of inequalities, we're going to sketch out the graph, and it's going to give us some region in the plane, and out of the x and y, the points x, y within that region, we want to find the ones that give us the largest value for z, as well as the one that gives us the smallest value for z. In other words, the minimum and the maximum. Okay, so let's see how this works in an example. So with any linear programming problem, you ignore the objective function to start out with. You simply look at the constraints and then sketch the region, just like we did in section 5.2. And this region, by the way, in the linear program is called the feasible region. Okay, so I'm not going to go through and carefully show how to sketch these regions. If you're uncertain as to how to do that, you should go back and look at section 5.2, where we work through it in some detail. But if I sketch the region determined by these constraints, I'm going to get the following shape. Let's see, let me just... Okay. Okay, and let me shade this in. Sorry, my marker's not really... Okay, there we go. My pen wasn't working for a second. Okay, so this is the region determined by those constraints. And so just like before, I need to identify where my vertices are. And I would do this by finding the intersections of the relevant lines and use the RREF calculator function. But this point is 5, 6. This point is 4, and this is 2. Okay, so once I have my region, I then need to determine... So this, just to kind of explain quickly, if I take any point in this region, then the x and y coordinates of this point will satisfy the constraints. And these are the only points that satisfy these constraints. If I take a point outside of the region, it will fail to satisfy the constraints. So what I want to do is, of the points in the region, or in other words, of the points that satisfy the constraints under which I'm working, I want to determine which one gives me the largest value for z and which one gives me the smallest value for z. And fortunately, it turns out that for a linear program, if there is a max or a min, it will always occur at one of these vertices. So what I need to do now is check my vertices. So after I sketch the feasible region and then figure out what my vertices are, I need to plug each one of them one at a time into the objective function. So if I check the point, so I have 4 vertices, 0, 0, and 0, 2, 4, 0, and then the point 5, 6. So let's say I plug 0, 0 in to the objective function. I get 0 plus 0 plus 10, so I end up with z equals 10. Plugging in 0, 2, I get 0 plus 20 plus 10, which is 30. Plugging in 4, 0, I get minus 28 plus 0 plus 10, which is minus 18. And then plugging in 5, 6, I have minus 7 times 5, which is 35, plus 10 times 6, so that's plus 60, plus 10 more. So that looks like 35 all told. Okay, so now I just need to find the smallest number and the biggest number out of these. So the biggest number is the 35, and the smallest number is the minus 18. So my answer here, let me clear out a spot to write the answer. My answer is I have a max of 35, a maximum of 35, and I also need to describe where it occurs at. A max of 35, which occurs at the point 5, 6, and I have a min, or a minimum, of minus 18, and that occurs at the point 4, 0. Okay, so this is the answer to this linear program. Let's take a look at another one. Okay, so just like before, this linear program consists of an objective function as well as constraints. And just like before, I'm going to begin by ignoring my objective function and then just sketching out the region determined by my constraints. So if I do that, we actually saw an example very similar to this in section 5.2, but the resulting region here, the region I end up with, if I sketch this out, if I sketch out this feasible region, is going to look like this. 4, 5. Okay. So I get a region that looks, whoops, I'm not sure what happened there. Okay, let's try that again. Okay, so I end up actually with a triangle that looks a little like this as my feasible region. And again, this is just found by drawing my constraints and then seeing which ones do or do not satisfy, determining which side of the lines that I need to use by seeing if 0 satisfies the constraint or not. Okay, and so then checking my vertices, this one I had sort of mislabeled. It was 5, 6. Okay, so getting this region is again just a review of what we did in section 5.2. So now that I have my 3 vertices, I need to check them by plugging them each into the objective function to see which one gives me the largest number and which one gives me the smallest number. So I'm going to check my vertices. So my 3 vertices are 0, 2, 0, 10, and 5, 6. So I plug each of those in for z. Plugging in 0, 2, I get 0 plus 10, so that's obviously 10. Plugging in 0, 10, I get 0 plus 50. And then plugging in this last one, I get 5 plus 30, which is 35. Okay, so my minimum is 10 and my maximum is 50. And summarizing that, my answer is as follows. I have a maximum of 50, and it occurs at 0, 10. And I have a minimum of 10, which occurs at 0, 2. Okay. And that's it for parts A and B. and I'll go ahead and solve C through F in a different video.